Okay, this is our first video on projectile motion. Now, a projectile is something that is thrown or fired into the air and it moves under the influence of gravity alone. So we know that gravity acts downwards, okay? We're going to ignore air resistance, okay? So when you throw an object into the air, it will move in a parabolic path or in the shape of a concave down parabola, okay? Now, what we do is we look at the very first moment that the particle is thrown. So we're going to look at its initial velocity. So girls, the velocity, the particle is thrown in this direction with an angle theta, but because gravity acts downwards, very soon the particle will come away from this path and it will go lower than that path. Does that make sense? And then it'll reach a maximum height and then it'll start going back down and hitting the ground. The important thing about parabolas is that they are symmetrical about the middle, okay? So this left side of the graph will be the same shape. Well, there'll be an axis of symmetry down the middle, okay? So the time taken, for example, to reach the top is the same as the time taken from the top to the bottom, okay? Now what we do, we look at the initial velocity, and initially at that split second in time we can draw a right angle triangle. So can you please put a right angle triangle symbol in that corner? Now, so we're going to consider a particle projected with velocity v at an angle theta to the horizontal. So this angle is to the horizontal. So these are initial velocities. At when, in other words, when time is 0. Okay? So the only thing you're allowed to draw the right angle triangle for is velocity. Okay, so we draw a right angle triangle for velocity, initial velocity, angle theta. So let's look at cos theta. So here's my triangle. So girls, this notation here, x dot means velocity, but in the x dot means velocity in horizontal direction. So girls, see how that is on an angle? It's made up of velocity. See the particle, you could say, miss, it's going across and up. Do you agree? If it's going that way, it's going across and up. So we separate the components of velocity into horizontal and vertical. So x dot, remember x dot means velocity, but the horizontal component of the velocity, and y dot is the vertical velocity, velocity in vertical direction, or the vertical component of the velocity. So you can break up that's basically a vector. You can break it up into two other, into the horizontal and the vertical aspects of the velocity. Of course, Pythagoras' theorem would apply here, that this x dot squared plus y dot squared equals v squared. Okay, sine, cos, tan works in this triangle as well, because it's a right angle triangle. So now let's look over here. We've drawn our right angle triangle. Initial velocities. Cos of theta is x dot over v. So therefore, can you see that? Cos of theta is adjacent over hypotenuse, which is x dot over v. Therefore, x dot is what? V cos theta. So therefore, x dot, which is v cos theta, is the initial velocity in the horizontal direction. Looking at this right angle triangle as well, sine theta is opposite over hypotenuse, so it's y dot over v. Therefore, y dot is equal to what? V sine theta. Now, these are really, really important. They won't be given to you. You have to know to draw that. Okay? Are we good? So, girls, a few things we can tell at the moment initially. Initially, the particle starts at the origin. So initially, when time is 0, x is 0 and y is 0. So girls, I've got an axis here, a y-axis and an x-axis. Initially, x is 0 and y is 0. But initially, the velocity, the horizontal component of the velocity is v cos theta. And initially, so see, I'm just trying to describe displacement initially. I'm trying to describe velocity initially. And we're going to describe acceleration initially. Because when you describe motion, it's always displacement, velocity, and acceleration. Okay? So initially, the particle's at the origin. So x is 0, y is 0. Initially, the horizontal component of the velocity is v cos theta. Initially, the vertical component of that velocity is v sine theta. Now, acceleration. Since gravity is the only influence on the projectile, the horizontal, so whenever you look at displacement, velocity and acceleration, you have to consider horizontal and vertical for all of them. So since gravity is the only influence on the projectile, gravity acts downwards, the horizontal acceleration is 0. So that means we can just put here x double dot is 0. And the vertical acceleration, so v double, well, we'll call it acceleration. I suppose we can call it, yeah, y double dot, yeah, y double dot, got it, is minus g. Why is it minus g? Because gravity acts downwards. Okay, now you're going to see in the next section that whenever you're going to be asked to derive equations of motion, and when you're asked to derive equations of motion, we always start with acceleration and integrate our way down. Okay, so we might write that note somewhere. So when you are asked to derive the horizontal and vertical equations of motion, you start with acceleration and integrate your way down. So you might put this in a cloud. So when you are asked to derive the horizontal and vertical equations of motion, you start with acceleration and integrate until you get down to x. So for example, we'll start with x double dot, then we'll go to x dot, then we'll go to x. And we will integrate. So that's for horizontal, because x is horizontal. Or you'll start with y double dot, you'll integrate to get y, and then you'll end up integrate again. That says integrate. Got it? Integrate. Let me make that bigger. So when you are asked to derive the horizontal and vertical equations of motion, you start with acceleration and integrate. But you have to do it separately for horizontal, and then you do it for vertical. So there's 6 equations that you have to do. Now, what often happens in the HSC questions, they ask you not to do that. They do that bit for you. They know that's the easy part. So they say you do not have to prove this. If you're lucky, you'll get up, they'll ask you to prove it, like to do them, because they're pretty easy. But often they don't. Often it's question 7, and it's hard, and you don't have to do the easy part. So you got that, girls? So we always start with acceleration, and we integrate our way down to get velocity, which is x dot y dot, and we integrate again to get displacement. All right? We're going to now we'll look at the horizontal equations first, and then we'll look at the vertical ones. So horizontal, girls, even though the particle is being thrown at that angle, the only force acting on it is gravity downwards. There's no sideways acceleration. Well, so because we're neglecting air resistance or any sort of friction, in the horizontal direction, acceleration will equal 0. So we start with x double dot equals 0 for horizontal motion. Then, to get velocity, which is x dot, isn't that the integral of 0 dt? So girls, we're back to time. We're doing velocity, acceleration, and displacement with respect to time. So acceleration is 0. To work out velocity, you integrate 0 with respect to t, and you get a constant. Because if you differentiate the constant, you get 0. So if you integrate 0, you get the constant. But what is that constant? Well, we know initially from our little thing up here that when time is 0, remember, when t is 0, the initial velocity in the horizontal direction is v cos theta. So we write that there. So we go, when t is 0, x dot equals v cos theta from our right angle triangle. So therefore that constant is v cos theta. Now that will be a constant because theta might be 45 degrees or 30 degrees or 60 degrees or whatever. Cos 60, for example, is a half, and the velocity was a certain velocity at the beginning. Maybe they're throwing it at 20 meters per second. So that will be a constant. There's no t in it for it to be a variable. Things are only a variable because we're integrating with respect to time. Because there's no t in this v cos theta, it's a constant. If there was a t in it, it would change as time changes. So this step, are we okay? So x dot equals c, but when time is 0, we know that x dot is v cos theta. Therefore, actually she's put constant 1. Therefore, constant 1 is v cos theta. Therefore, x dot equals v cos theta. Because x dot is the constant and the constant is that. There is no substitution to make for any particular t because there's no t. But we know that initially the velocity in the horizontal direction is v cos theta. So now, are we okay? So now x, which is the displacement, is the integral of v cos theta dt, which is what? How do you integrate that? That's just a constant.
Vt cos theta plus c.
Yeah, it's v cos theta times t plus c, or vt cos theta plus c. So girls, the reason I put times t here is v cos theta is just a constant. It will be just a number. Because cos of the angle is just a number, velocity is just a number. So when you integrate that, you get whatever that is with the t thrown on the end. But we like to, if you put the t next to the theta, it's going to look like cos of theta t, which it's not. So it's v cos theta times t. Write it as vt cos theta. Do we know anything initially when t is 0, where is the particle? When time is 0, x is 0 because the particle is in the corner. So substitute over here. We're coming over here now. When t is 0, x is 0 because the particle started in the corner. So therefore, 0 equals 0 plus c. Actually, we want c2 here, by the way, the second constant. Because that was constant 1. We've now got constant 2. So we'll call it c2. Therefore, the constant is 0. Because you put 0 and 0. So therefore, x is vt cos theta. Now, you don't get given these equations. Sometimes they give them to you and say you don't have to prove it. You don't just pull them out. You have to know how to derive them. Okay, so that is horizontal motion. This was here. Unless otherwise indicated, every projectile motion question begins with acceleration in the horizontal direction is 0 and acceleration in the vertical, it's already written on the page before. And acceleration in the vertical direction is negative g. All other equations are derived from this by integrating. By integration. Okay? Sorry, I made you write that on the other page. I forgot that it was there. Okay? So it's all there. So let's start with vertical motion. We've got vertical motion in the, vertical acceleration is gravity acting downwards. So it's negative g. So therefore, y dot velocity in the vertical direction is the integral of negative gt dt, which is negative gt, throwing a t onto it, plus c3, the third constant. Now, when t is 0, do you remember our triangle? Remember how we had the triangle v, x dot, y dot? Do you remember that? And we had sine theta is y dot on v. Therefore, v is y sine theta. This was initial velocity from the page before. So when t is 0, which is initial velocity, sorry, I should put y dot. Sorry, y dot is v sine theta. So when t is 0, y dot is v sine theta. So therefore, we're going to substitute it into here. V sine theta equals negative g times 0 plus c3. Can you see that? Can you see it? So we put that in. Y dot. v sine theta equals negative g times 0 plus c3. Therefore, c3 will just be v sine theta. So therefore, the equation for y dot is what? Negative gt plus what? Plus v sine theta. That's what the equation for velocity in the vertical direction is. Now, y will be the integral of that. The integral of negative gt plus v sine theta dt. So you're integrating with respect to time, and you will get what? Negative what? G t squared on 2 plus sine theta plus constant number 4. So we have to make a substitution for y and t to work out constant number 4. So looking back at the very original particle that was thrown, which was thrown from the origin, when t is 0, y is 0, so therefore 0 equals 0 plus C4, so C4 is 0, because if you put 0 there, it's 0. If you put 0 there, it's 0. So therefore, y equals negative gt squared plus vt sine theta. And that is the vertical equation for displacement. So these are called the parametric equations because they're describing x and y in terms of t. So do you remember parametrics? Now you can work out the Cartesian equation of motion. See girls, I've got x is vt cos theta from page 1, and I've got, that's the horizontal motion for horizontal displacement, and I've got y equals negative gt squared on 2 plus vt sine theta. That's the second equation for the vertical displacement. I can eliminate the parameter t and make the equation in terms of y and x and theta only, and eliminate t, the parameter. So to find the Cartesian equation, I need to eliminate parameter t. So if I rearrange equation 1, so x equals vt cos theta, if you make t the subject, what do you get? So we get t is x divided by v cos theta. You then substitute that into equation 2, and you will get, there's equation 2, so when I see the t, I have to replace it with x over v cos theta. So negative g over 2 x over v cos theta squared plus v, bring the t in, x over v cos theta again, times sine theta. So girls, what do I get? I get on the numerator negative g, what do you get? X squared over 2, what do I get here? V squared cos squared theta. Girls, because I've got to get x squared over v squared cos squared theta and times that by negative g on 2. And then that gets added to, what's on the numerator? Vx and sine theta are on the numerator. So I get Vx sine theta over, what do I get here on the denominator? V cos theta. Now we can see what's going to cancel.
The sine and cos becomes 10.
That's right. And 1 on cos becomes?
1 on cos becomes, but you bring the sec up.
That's right. So I'll keep the negative gx squared over 2v squared. 1 on cos is sec, so I'm going to put sec squared theta up, plus the v's cancel, and sine theta on cos theta is tan theta, and I get x tan theta. So now we've got that in the box down there. So therefore y is equal to negative gx squared on 2v squared sec squared theta plus x tan theta, or we know from 2 unit that it's, that's right, 1 plus tan squared equals sec squared. And sometimes that's useful if you want to, we do use that sometimes when we want to solve for theta. We use the 1 plus tan squared, you end up with a quadratic, and you can solve for theta later. That's when we do questions like at what angle does the particle hit the ground and stuff like that. Okay? And we'll have to use the Cartesian equation Or sometimes we can use the velocity ones to do it. Are we okay? Now, I'm thinking, flight. Remember, we've got a projectile. You've got to think that the particle hits the ground here. Now, it starts there. Particle leaves, angle theta. The particle hits the ground when what is what? You tell me. When y is 0. That's it. So if you, ladies, if you're ever asked about the time of flight, well, yeah, the particle hits the ground when x is something. I don't know what x is, but it's easier. Well, we have no idea what the x is, but the particle hits the ground when y is 0. So that's what we do. So the particle finishes its flight when it reaches the ground. In other words, when y is 0. So we know, see, once you've come up with the equation for the x and y, for the horizontal and the vertical components of displacement, you can then answer questions like what's the time of flight, what's the maximum height reached, and what was the maximum range. They're the 3 things they're going to ask you. So how long does the flight take? Number 1. That will happen when it's hit the ground when y is 0. So you take your y equation, which is negative gt squared on 2 plus vt sine theta, and put y equal to 0 and solve. So let's do that. And we've got 0 equals negative gt squared plus vt sine theta. Taking everything over to the left because we don't like to have negative t squareds, we get gt squared minus vt sine theta equals 0. Because it's a quadratic, you have to factorize it. That is the only way you solve a quadratic equation is by factorizing. So taking t out as a common factor, what do I get? gt on 2 minus v sine theta. So we took t out, we're left with gt on 2 minus v sine theta equals 0. So therefore t equals 0, or we need another line. So therefore t is 0, or gt on 2 minus v sine theta is 0. Can we make t the subject now? So therefore t is, wouldn't you take the v sine theta to the other side? And once it's over the other side, you put the 2 up and the g down. Divide by g times by 2. So you go 2v sine theta on g. So girls, you take that over, the 2 goes up and the g goes down. Are we good with that? So t equals 2v sine theta on g. You don't learn these, girls, at all. You just have to know. So girls, all you'll have to do after this, they're not on the formula sheet, you have to know how to derive them. But in your questions, you'll be given the velocity, or you might be given the angle, all right? But the process will be the same. In all the questions you're going to get, you're going to derive the equations, and then you're going to be asked for the time of flight, or you're going to be asked for the maximum range, or you're going to be asked for the greatest height. Are we good? So maximum range, girls, again, looking at that particle and how it travels, it goes like that. Maximum range is when what? It's this distance here. So my maximum range, how far does that particle go, is here. That's my maximum range. What do you know about that point? Only the time, isn't it? From the part before. Well, it happens. No. Yeah, well, that will affect how far it goes. But to work out that distance, if you know how long the time took to get to the ground, you substitute your time into which equation to get that value of x. Time. See, girls, you'll be substituting into one of 2 equations, the y equation or the x equation. So to do the maximum range, you need 2 steps. You need to know how long it takes to hit the ground by putting y is 0. And then, so this is maximum range. And that will occur when y is 0. And once you put the y is 0, you work out the t. So this is the horizontal displacement when the particle ends its flight. So it happens when t is 2v sine theta on g, what we worked out from the part above. So therefore, maximum range, we know that x equals vt cos theta, because that's the equation that we worked out from the first page. So we substitute in this value of time, because that's when it hits the ground. So 2v times 2v sine theta over g times cos theta. And what do we get there, girls? What can you, so 2, what else? V squared sine theta cos theta on g. Now, yes, fantastic. 2 sine theta cos theta is the 3-unit double angle result. So therefore it's v squared sine 2 theta on g. I'm just going to put here since sine 2 theta equals 2 sine theta cos theta. Make sure that's far away from that. So we're replacing the 2 sine theta cos theta with sine 2 theta. So girls, the maximum value of sine 2 theta, if I was to draw the curve sine theta, it's like that. If I want to draw the curve sine theta, that would be 2 pi and that would be pi. What about sine 2 theta? What's the period? 2 pi on 2. So that's the period, pi. What's the maximum value for that curve? 1. So the maximum value is 1 of sine 2 theta. So if you substitute 1 into sine 2 theta, you get, so if you substitute sine 2 theta for 1, because we want the maximum range, you get v squared times 1 on g. Okay? You'll get, when we do some questions, you'll so there's the maximum value there. Maximum value of sine 2 theta is 1. Because I've drawn the sine 2 theta curve there, its maximum value is 1. So therefore the maximum range is v squared on g. There are 2 ways of working out the greatest height. Probably the most sensible and easiest way is to do the derivative. So girls, whoops, so greatest height. So girls, again, I've just drawn the motion of the particle. The particle leaves here from the origin at an angle of theta. Goes like that. Here's the greatest height up there. That's your greatest height. And that is when y is a maximum. Do you get that? That's the maximum for y. If you want to find the maximum for y, you differentiate. There's 2 ways to do this actually. You know, if you know what t is, you can just halve the t and substitute it into the y. That's one way of doing it.
Is this always symmetrical?
Yes. But you've got to be careful. Sometimes it won't be. If you're throwing it off a balcony or off a cliff, then it won't be. And you need to use this. The only time... Okay, so we've got that the maximum range is v squared sine 2 theta on g. Now we know what g is. It's a constant, -10. They'll give us the velocity. But the problem here is that, yes, it is. It is. Okay, so if they ask you for just the range, you just substitute your values in and you'll get a range. Do you understand? But if they want the maximum range that this particle could ever be thrown at, then you're saying to me, Miss, that would occur when it's 45 degrees, right? And sine of 90 is 1. So that does occur when it's 45 degrees. But if you don't know the angle, what you do, if this is the curve for sine 2 theta, do you get that that's the curve? What's the maximum value of that curve? 1. So the maximum value for sine 2 theta will be 1, according to that graph. That's how you get the maximum range. But if you just ask for the range, that's only if you ever ask for maximum range. How far that could go as a maximum. But if you actually just ask for the range of your particle, you wouldn't do that. You only do that if you ask for maximum range. All right? All right. Look, we've got to do a lot of questions anyway. So as we do them, they'll be more easier to understand. So greatest height is when y is a maximum. So if you want y to be a maximum, you differentiate it and you get y dash. Now we already know that y dash from our equations of motion is negative gt plus v sine theta. So rearranging this, so you've got to put y dash equal to 0. So greatest height is when y dash is 0. So putting that equal to 0, taking the gt over, what do we get? Gt equals v sine theta. Therefore, t is v sine theta on g. Now, girls, before you go on any further, look at that value. T is v sine theta on g. Go back up to time of flight. 2 times v sine theta on g. Your time of flight is double the time to reach the maximum height. Do you see that? But that will only happen if the particle starts on the ground and finishes on the ground. So the particle will reach the greatest height at half the time it takes to reach the ground. All right? That's why we've got t is v sine theta on g, whereas before time of flight is 2 times v sine theta on g. So another way you could work out the greatest height is to halve the time of flight in the first place instead of differentiating, but we've got the derivative anyway. So we substitute this t into your equation for y. Now our equation for y is negative gt squared on 2 plus vt sine theta. So we get negative g on 2 v sine theta on g plus vt is v sine theta on g. So we get negative g v squared sine squared theta over 2g squared. Be careful that g is squared. Plus v squared sine squared theta over g, which is, yes, we can cross out some g's. So we've got negative v squared sine squared theta over, so one of these g's cancels with that, over 2g plus, you know what I want to do here, girls? I want to make the denominator here 2g as well. So I'm going to go plus 2v squared sine squared theta over 2g. Do you see what I've done? What I've done is one of the v's here cancels with this v to make my denominator 2g. But the denominator over here is just g. So I'm going to multiply the numerator and the denominator by 2. Now that I've got a common denominator of 2g, what is negative v squared sine squared theta plus 2v squared sine squared theta? 1v squared sine squared theta. So if you could please fix this sheet up, height is v squared sine squared theta on 2g. Instead of this first step, or you can say time to reach greatest height is 2v sine theta on g divided by 2, which is v sine theta on g. That is from part 1 above, from the time of flight. So the time to reach the greatest height is half the time of flight, or it is half the time of flight to reach the top. But that only occurs, it's divided by 2, which is times a half, which means you put 2 over 2. But girls, you only ever use that, please. The reason it's not here is that you would only ever use that. Only use if the particle starts and finishes at the ground. Otherwise, you can't use it. Yeah, it has to be symmetrical, otherwise that won't work. Use only if it starts and finishes on the ground. So I wouldn't be relying on it as my method. So use only if the particle starts and finishes on the ground.